Bismillahirrahmanirrahim. Hi dear students. In the last video we discussed about the structures and structural members, but we didn't discuss the structural members in detail, but we discussed only the names of the structural members which are used to compose a structure. At the first number we discussed about the first structural member, which is beam or beams. What is a beam? First of all, we should know that what is a beam. A beam is a horizontal member, which faces what? This faces bending forces due to applied loads. When a load is applied on a beam, then bending stresses are developed in the beam section. So I will show this bent section of a beam due to applied loads. Suppose we have this beam section and some type of load. Suppose we have a moment load applied at this point, and these are two supports at the end of the beam. When this moment will be applied, then this beam will bend like this. As the applied load has introduced bending stresses in the member, so it has a deflected shape like this. This is called deflected shape of beam. Why this deflected shape of beam is obtained? Because the applied moment or any applied force, this may be concentrated load, this may be uniformly distributed load, this may be triangular loading, any type of loading which may act on a structure, then this beam will deflect and there will be a deflected shape for the beam. Why this deflected shape is developed? It is developed due to bending stresses which are created in the beam sections due to applied forces. So beams are horizontal members which faces bending forces or bending stresses due to applied forces or applied loads. Now we will discuss different types of beams according to different classification systems. So first of all, we will classify the beams classification depending upon end supports or support conditions. First of all, we should know about the supports. What the supports are? A support may be, there are different supports which are used in beams or other structural members. So mainly there are 4 types of joints which a structure make. First joint is known as first support in a beam is known as fixed support. This fixed support has 3 reactions in total. When you see this type of support in any structural member, then what comes in your mind? That it has 3 reactions. Which type of reaction? Suppose we have this fixed support at this place in the member, then the reactions of this part would be, free body diagram will show the reactions. This is a vertical reaction of this support, this is horizontal reaction of this support, and this is moment reaction of this support. Suppose we call it as V, V, this has H, and we can say it as vertical reaction, horizontal reaction, and moment reaction. Suppose this is point A, then we can call them as VA, HA, and MA. Moment at A due to applied loads, vertical reaction at A due to applied loads, and horizontal reaction at A due to applied loads. Then it means that at a fixed support there are three type of reactions when vertical reaction, one is horizontal reaction, and one is moment reaction. This is first type of support, that is fixed support. Second type of support is a pin support or a hinge support. A pin is shown like this. This is pin and this is solid support. This is pin support. A pin support has two reactions in total. One is vertical reaction, one is horizontal reaction. Suppose we have this point B, then this vertical reaction is known as VB and this horizontal reaction is known as HB. So we can say that in a pin or a hinge support we have only two reactions. Moment is not present in the case of this support, as this is a pin and this member can rotate. It can go this way or this way. So there is no restriction of moment. Uh, so we can easily say that this support cannot resist applied moments. It can go in this way or in this way and has no resistance against the moment, so there is no moment reaction. But this support, fixed support, has resistance for moment, so this is a moment reaction. So fixed support has three reactions and pin support has two reactions. Third support is known as roller support. This roller support is shown by different ways. Suppose this is our beam and roller support is shown like this. First figure of roller support. Roller support may be shown like this. This is also form of roller support, and a roller support may be shown like this is also a roller support. The roller support may be shown by different scenarios or different symbols. So we can say that this beam can go this way or this way, this way or this way. This can rotate as well and go in horizontal direction as well. So it has only one restricted way, that is vertical. So a roller support has only one reaction. So we have decided that fixed support has three reactions, pin or hinge support has two reactions, roller support has only one reaction. And on the next way we have internal hinge. Internal hinge is shown as a dot or as a pin between two connected points, two connected members. This is a beam. Suppose we have beam and we want to make it stable or according to equilibrium conditions, or we want to apply the equilibrium conditions on this member, then we can introduce a internal hinge in this member. So it has no reactions. It can rotate, it can move horizontally, it can move vertically, it can rotate. So there is no restriction for vertical movement, for horizontal movement, and for bending movement. So there is no restriction, then there is no reaction for a internal hinge. So these are four types of supports which are mainly used in civil engineering structures. Now we can discuss beams in detail, types of beams. So first type of beam, beams are classified according to different classification criterion. The first criteria for the beam classification is depending upon, as we discussed on last page, that depending upon support conditions. Support conditions. we have known, we have studied about the supports. So now we can understand easily what the support means. Support is any obstruction provided at the ends or any location of a member to restrict any type of movement, bending or vertical movement or horizontal movement. So according to support conditions, first of all we have cantilever beam. A cantilever beam is that which has, so by drawing the figure we can understand the cantilever beam. A beam which has fixed support at its one end and the other end is free. Fixed support at one end and other end is free, then this beam is known as cantilever beam. The second type of beam is simply supported beam. Simply supported beam. So this beam is shown as one side of the beam is pin supported and other side of the beam is roller supported. It means that if a beam has pin support at its one end and the roller support at its other end, so it means that this can be like this as well. Roller support at this end and pin support at this end. So only the condition is to have roller support at one end and pin support at one either other end. So they may be either way. Pin support may be on the near end or roller support may be on the near end. So third type of the beam according to support condition is overhanging beam. What is overhanging? Its name shows that overhang. Overhang means we have a simply supported beam. For suppose we can suppose that we have a simply supported beam, but the roller support is not present at the far end, but it is somewhat near to the pin support, but there is a free end. It means that if a beam has a free end at the far corner, but it has two or more supports, then this beam is known as overhanging beam, that its one end is in air. And the fourth type of beam is continuous beam. A continuous beam has two or more continuous spans. We can show it as this is a hinge support, this is a roller support, and this is a roller support. It has two spans, one span number one, span number two. It may be like this as well. We have fixed support at this end, roller support at this point, and a hinge support at this point. So this has also 2.2. We can adjust here as a roller, and this will go this way till this support. This has three spans, 1, 2, 3. This is a continuous beam having three spans, and this is a continuous beam having two spans. On fifth number, we have fixed beam. As the name suggests, that this beam has both ends fixed. Both ends fixed mean this end has a fixed support and this end also has a fixed support. So one end and second end, near end and far end, both has fixed support. So the beam will be a fixed beam. So these are five types. First type of beam is cantilever beam according to support conditions, simply supported beams, overhanging beams, continuous beams, and fifth type is fixed beam. Now the second classification criteria is according to their geometry, according to their shape. there are different shapes of beams available. So first of all, the mostly used shape is a rectangular shape beam. Rectangular shape you have seen many times. This type of beam is a rectangular. This is breadth. This is height of beam. Breadth is less as compared to height. This is a rectangular shape beam. Second type or second shape of a beam is a I shape. As name suggests that it will be like I. This one. This beam is a I shape beam. Third shape of the beam possible is T shape. So it is also suggested by the name that it will be like a T. This is a beam. This portion is known as flange. This portion is known as web. So in case of I beam, there are two flanges. This is flange number 1. This is flange number 2. Two flanges and one web. So fourth type of shape of beam is rectangular shape, I shape, T shape, or fourth type may be invert beams. Inverted beams. So inverted beams are, suppose we have slab like this, and some beams are extended above the roof. Suppose this is 2-inch extended above the roof and 6 inches below the roof, and they are cast monolithically with the slab. So we have these two criterias of the classification of beam. First of all, depending upon the support conditions, and the second criteria is depending upon shapes of beams. On depending upon the support conditions, we have cantilever beam. A cantilever beam is a beam having one end fixed and other end free. Free means there will be no support on this end. Second type of the beam depending upon support condition is simply supported beam, that it will have pin support or hinge support at one end and roller support at the other end. This is also a pictorial view of simply supported beam. This is also a pictorial view of the simply supported beam. Third type of the beam is a overhanging beam. Overhanging beam is such beam which has two or more supports, but its one end is free. And fourth type of the beam is continuous beam, that it has supports at its both ends. You can see in this image, it has hinge support, it has a roller support at the other end. So we can see in the image 2 that this has fixed support and this is roller support at the far end. So in continuous beam, there are essentially two supports at the ends, and there will be an inner support at any location. It may be at this location, it may be at this location, or any location. So it will have two or more spans. This is a continuous beam. And the fifth type of beam is a fixed beam, that it will have both ends connected with the fixed supports. This is a fixed support symbol, this is a fixed support symbol. So this beam is known as a fixed beam. Then we discussed about the shape of the beam, different shape of the beams available or being used in the civil engineering structural constructions. So first shape of the beam is rectangular shape like this one. Second shape is I shape, this one. It has two flanges. This is known as flange, and this portion is known as web. So this is flange, two flanges. And next shape is a T shape like this one. It has only one flange at the upper part and a web at the lower part. And the inverted beams are also available sometimes, where we have height restrictions in our buildings. So this beam is inverted towards the roof. So these are known as inverted beams. The third classification criteria of the beam is geometry of the beams. According to geometry, there are three types of the beam. First type of beam is a straight beam. A straight beam means its section will be like this, straight and continuous section. Continuous mean it will have same section parameters on both sides. If at this end it has 9-inch breadth and 12-inch height, then at this end it will also have 9-inch breadth and 12-inch height. So this is known as a straight member. There is no change of way along the whole length of the beam. So second shape of a beam is curved beam. So straight, what, how can you get an idea about the straight beams? So in most of the structure, in normally built structures, straight beams are used, and curved beams, so we can have an idea in curved beams. This may be an example of curved beam. There may be a minute, a little curve, but we cannot see it with the naked eye. This may be a shape of curved beam. So these beams are used in pre-stressing or pre-stressed constructions. And third type of beam according to the geometry is known as tapered beam. As we can see in this type of beam, in straight beam, that this section had equal dimension on both sides, but in case of tapered beam, it will have different sectional dimensions on either ends. This end has smaller dimensions and this end has larger cross sectional dimensions. So we can differentiate different types of beams according to their shapes, according to their geometry, and according to their support conditions. Thank you very much. See you in the next video.